continue our discussion on the indeterminate form using L'Hopital's rule. Yesterday, we have discussed ito, 'di ba? Na indeterminate form, 0/0 and infinity over infinity. Today, we will be discussing naman another indeterminate form wherein kapag nakuha natin is a product of 0, no, times or multiplied by a positive or negative infinity. So, this is an indeterminate form. And hindi yan hindi yan zero because this is one of the indeterminate form. Okay. Sorry. And then we also have kapag infinity to be subtracted by infinity. So that is also an indeterminate form. So if the limit of f of x as x approaches to a, no, is equivalent to 0, and the limit of g of x as x approaches to a pa rin is equivalent sa positive or negative infinity, then the function defined by the product of f of x and g of x is said to have an indeterminate form na ganito. Okay, basically a product of 0 and positive and negative infinity. Now, forms of this type can be changed into the form of this one and this one. Kasi kung uh, after direct substitution, no, pag nakuha natin ganitong form, it would be the L'Hopital's rule will not be applicable. So, kailan lang yung magiging applicable yung L'Hopital's rule? Kapag meron tayong form na ganito. So, from here, from this form, kailangan natin yan i-change or i-convert into this form. And so, how can we convert that into that form so that we can apply the L'Hopital's rule? Ito lang yun, no? To effect this change, we rewrite the f of x multiplied by the g of x into any of the following forms. Pwede yung f of x, i-retain nyo yan dun sa numerator, and the g of x, kunin nyo yung reciprocal niyan. So, basically, di ba, from f of x, g of x, ginawa natin itong g of x, nilagay natin dito sa denominator, mangyari niyan, f of x, then yung sa denominator, magiging 1 over g of x. Tama ba? Okay, kasi kung atin tong ibabalik dito sa numerator, magiging ganito lang din yan, no? So, you take lang the reciprocal para mailagay mo yan dyan sa denominator. So, depende lang yan, ha? Pwede din yung f of x yung kukunan nyo ng reciprocal, no? Tapos ilagay sa denominator. Okay? In general, one form is better than the other, but the choice depend upon the given product. So, magdedepende yan, ha? So, ano yung mas convenient na ilagay sa denominator, yun yung gagamitin natin. Okay? So, it would be case-to-case basis, kumbaga. Okay, let's try to solve some problem. Example number 1. Evaluate the limit, okay, of the function x cotangent x when x is approaching to 0 or as x approaches to 0. So, first, if we try to directly substitute this one, ang mangyari niyan, we have here 0. Tama ba? And cotangent of 0. Itong x, 0 yan, automatic. Itong cotangent of 0, ang makukuha natin yan is positive, negative infinity, or simply positive infinity. So, that is an indeterminate form. Hindi natin to ma-determine. Kung gusto nyo i-try, no? Kung gusto nyo i-try using your calculator, hold on. Kukuha lang ako ng calculator. Kung gusto nyo yan i-try sa calculator, okay? Okay, that is, okay, make sure na naka-region mode kayo, ha? Region mode. Okay. Then, alpha x. Then, di ba yung cotangent, that is 1 over tangent of x, no? Then, calc tayo when x approaches to 0. So, you would get math error. So, basically, that is an indeterminate form. So, di ba? So, we have here this form, no? So, we will be converting this form into yung quotient ng 0, 0 or infinity over infinity. So, to do that, either one of these, di ba, dalawa man ito, yung f of x, ito yon. Then, g of x naman ito, no? So, either f of x or g of x, dapat kukunin natin yung reciprocal diyan. So, ang pinakamadali dito is yung cotangent of x. Kukunin natin yung reciprocal niyan. So, ang mangyari niyan, we have here x all over, yung reciprocal ng cotangent x is 1 over cotangent x. Tama ba? Pero we know that, okay, so sulat natin yung limits as x approaches to 0. Pero we know that yung 1 over cotangent of x is simply tangent of x. Yan yun, di ba? Itong 1 over cotangent of x is simply 1 over tangent of x using the reciprocal identity ng trigonometry. Now, we now have this form. So, dito na tayo mag-a-apply ng L'Hopital's rule. Okay, applying L'Hopital's rule, LHR. So, we have here limits as x approaches to 0. So, yung derivative ng x is equivalent sa ano? 1, di ba?
1.
Okay, how about the derivative ng tangent of x? The derivative of tan x is equivalent sa ano?
Second squared.
Second squared of x, di ba? And then, if we will be evaluating, so ano yung value ng second x, second squared x? So, di ba yung second squared x is equivalent yan sa 1 over cosine squared. And then, yung value ng x is 0 daw. Di ba? Yung second is equivalent sa 1 over cos. Kaya, kung naka-square yan, naka-square din yung cos. So, kung kukunin natin yung calculator natin, then if we will be evaluating that one, okay, 1 over 1, okay, 1, okay, sorry, okay, gawin ko lang ha, 1 divided by 1 over cosine, okay, cosine 0, then square, okay, you would get 1. So, this one is equivalent lang sa 1. Okay. Basically, yung yung limits ng etong function na to x cotangent x as x approaches to 0 is equivalent lang sa 1. Okay? I hope nakuha nyo, no? So, any questions regarding this problem? Hello?
None.
None so far. So, as I've said, kapag meron tayong indeterminate form na ganito, you just need to convert it to this form, either of these two. And then after which, pwede kayo na mag-apply ng L'Hopital's rule or LHR. Okay, sige. Sample number 2 tayo. Evaluate the limit of secant x minus tangent x as x approaches to pi over 2. So kung if we will be evaluating this directly, no? So yung secant, 'di ba, 1 over cos 'yan, then pi over 2. Okay, 1 over cosine pi over 2 minus yung tangent, 'di ba, sine 'yan, sine x over cosine x. So that is sine of pi over 2, then cosine of pi over 2. Tama ba? Then using our calculator, yung cosine pi over 2, that is 0. Okay, that is 0. Itong cosine pi over 2, that is 0. At saka yung sine pi over 2 naman, okay, that is equivalent sa 1. So, kung gusto nyo i-prove, no? Okay, pakita ko lang. Sin pi over 2, that is 1. Okay. Now, kapag ipa-plug in natin yan, we have here 1 over 0, no? Minus 1 over 0 din. So, we have here what? Indeterminate form yan kasi yung denominator is 0 or are zeros. So, kapag ganyan, no? So, anong gagawin natin? We will be applying L'Hopital's rule. But first, we need to we need to find a way na itong secant tsaka yung tangent, mako-combine natin yan. We know that secant is cosine of x. And we know tangent is sine of x over cosine of x. So we have here two fractions having the same denominator. So we can just combine. Okay? So that is pi over 2. Combine natin yan. Okay, what is the combined form of this one? That is cosine of x, yung numerator 1 over sine of x. Then, kapag i-evaluate natin yung pi over 2 as x approaches to pi over 2, the same pa rin yung kakuha natin. Indeterminate form pa rin. So, let's apply, no? Let's apply L'Hopital's rule. L'Hopital's rule. So, limits as x approaches to pi over 2, no? And the derivative ng 1 over sine. Kindly give me the derivative ng 1 over 1 minus sine x.
Negative cosine.
Okay, negative cosine of x. Kasi yung derivative ng 1 is 0. Derivative ng sine x is cosine. Meron tayong negative dito. Kaya nagiging negative cosine x. How about naman ng derivative ng cosine x?
Negative
Okay,
sine.
negative sine x. Di ba? Ito matatanggal yan. Okay, ma-eliminate yan. So, we now have the limits as x approaches to pi over 2 of cosine x. Then we have here sine x. And cosine x or cosine pi over 2. And we have here sine pi over 2. We know cosine pi over 2 is 0. So we have here 0 all over 1. Or that is equivalent sa 0 pa rin. Okay, so yung sagot dito is actually 0. Okay? Nakuha nyo ba? Hello?
Yes po.
So I will be teaching you
Yes, sir.
a ano no, a calculator techniques just to check lang yung sagot na 0 talaga yan. So, sa calculator, pwede nyo gawin, di ba, yung cosine, yung second is 1 over cos, no? Ilagay nyo yan dyan, 1 over cos x, no? Bale, you need just to input the original function here. So, yung tangent, tangent pa rin yan, no? Then, sabi dito, yung tinuro ko ganit sa inyo, yung sabi dito, you evaluate as x approaches to pi over 2. So, yung pi over 2, calc natin yan. Di ba kapag ilagay natin dyan, pi over 2, automatic magiging math error yan. Kasi, that is, ito yan, no? Di ba? Pero, kung maglagay kayo ng calc, no? Pi over 2, hindi kayo di ba, mag-exactly pi over 2, maglalagay kayo ng 0.000 here. Mean to say, you are approaching pi over 2, but not exactly pi over 2. You would get what? Okay, kung atin tong i-expand, no? You would get approximately equal yan sa 0. Okay, 0 yan. Okay, ito yan, 0. Hindi yan negative 0 kasi 0, wala yung sign, negative or positive yan. So, 0 yan, diba? Tama ba? So, kagaya nung first, okay, ito, try natin ha. Gaya na itong first, we have here alpha x, then cotangent, di ba? 1 over tangent yan, tangent of x, di ba? Then, sabi dito, approaches to 0. So, calc natin, kung 0 natin ilagay dyan, that is equivalent sa math error. Pero kung calc 0, mag-add tayo ng 0.0001, meaning to say, palapit tayo sa 0, then you would get exactly 1. So, that is the same thing as this one. No? This is just used for checking, but not as your solution. So, need nyo talaga ay apply ng L'Hopital's rule. Okay? Nakaintindihan ba tayo, guys? Hello?
Yes, sir.
Is this clear to you?
Yes, sir. Yes, sir.
Okay. Okay, let's proceed, no? Problem number 3. You evaluate the limits as x approaches to 0 for the function x squared ln x. So, kung atin tong ilagay directly yung x, diba, 0 squared, then yung ln of 0, that is actually positive infinity. So, ang mangyari nito, we have 0, tapos positive infinity. That is an indeterminate form. Kuha ba? That is an indeterminate form. So, kapag ganyan, gamitin natin yung rule, no? So, dito, mas madali dito, di ba, this is your f of x. And this one is your g of x. So, di ba, either f of x then 1 over g of x or g of x over 1 over f of x. So, madali dito, yung x squared ang ilalagay natin sa denominator. So, you would get ln of x, okay? Kasi kapag ln of x yung ilagay, so unahin natin yung ln of x over 1 over x squared, di ba yun? Di ba yan yung mangyayari? Kapag ilagay kasi natin yung ln of x sa denominator, okay, we have now ln of x and we don't have a direct derivative for this one. Pero meron tayong direct derivative for ln of x, no? Pero sa ganito wala tayong direct na derivative niyan. So mahirap 'yan. So for this case, yung f of x yung ilalagay natin sa denominator. Okay? So you would get here, kasi yung derivative ng ln of x, we know that that is 1 over x, no? 1 over x. Ang derivative ng 1 over x squared is negative 2 over x cubed. Tama ba?
Yes, sir.
Okay. So, etong x, makancel yan, matira dito is 2. Etong x squared, mapunta yan sa numerator. Mangyari niyan, we have x squared x raised to the power of 2 or x squared all over negative 2. Now, you will evaluate when x is equivalent to 0. So, 0 squared over negative 2, that is simply equivalent sa 0. Kuha ba? And then, kung i-try natin ilagay dito sa calculator, just to prove, no? X squared, okay, sorry. X squared, then ln of x, no? Calc natin when x approaches to 0, so 0 plus 0.0001, you would get, ano to? Okay, negative. Okay, ano yan? Ano yan? Shipping natin. O, di ba? Approximately equal sa what? 0. Okay, 0 na yan. Oh. So, yun yung way, no? Just to check. Okay. Okay, nakuha ba itong problem na to?
Yes, sir.
Yes,
Okay.
sir.
I hope that's clear to you, no? So, problem number 4 tayo. And then, problem number 5. Tomorrow na to, class. So, this is the last topic na supposedly will be included in your exam on Thursday. Supposedly Thursday. So, we'll be extending, or meaning to say we will be postponing our exam from supposedly Thursday to next week Thursday. Okay, I will be telling you the reason later. So, pero proceed tayo sa example 4. Okay, evaluate. Okay, this function pi over 2 minus x tangent x when x approaches to pi over 2. Okay. So, 'di ba kung ilagay natin 'yan diretso pi over 2 minus pi over 2, so ano to? Yung x ba? Pi over 2. 0 na 'yan, 'di ba? Automatic. Then tangent of pi over 2. Ito, kung ilalagay nyo sa calculator, you would get math error for this one. Itong tangent pi over 2 because yung tangent pi over 2 is ano, a positive infinity. So, 0 times positive infinity, you would get an indeterminate form. Kuha ba? So, pag ganyan, okay, pwede natin gawin is yung f of x na ito, f of x, then ito, g of x, di ba? So, ilagay natin yung f of x sa numerator pa rin. Then, sa denominator, reciprocal ng tan x. So, that is just this one. No? Ano ba yung reciprocal? Okay, ano ba yung other form ng reciprocal ng 1 over tan x? Everyone? Ano yung identity niya? Reciprocal identity ng 1 over tan x. Diba that is equivalent sa ano? Sorry. That is equivalent sa cotangent of x. Tama ba? And then, if we will be evaluating the derivative ng pi over 2 minus x, that is simply negative 1. Tama? Hindi. Hello? Are you still there, guys?
Tama, sir.
Okay. Kasi yung pi over 2, that
Okay,
is a
sir.
constant. This is a constant. Tama ba? This is a
Yes, sir.
constant. And then, yung x is a variable. So, derivative ng negative x is negative 1. How about yung derivative ng cotangent x? Ano yung derivative ng cotangent x? Nalala nyo pa, class? That is negative
Negative C
cosecant.
squared.
Okay, squared x. Tama, no? So, yung negative, makancel yan. So, therefore, we have here a limit as x approaches to pi over 2 for 1 over cosecant squared x. Okay, x. So, kung evaluate natin yan, 1 over, di ba yung cosecant x is 1 over cosecant x, that is simply sine, no? Sine squared x. Ito ba? Sine squared x yan. Kuha ba? Then, you evaluate when x equivalent to pi over 2. Di ba yung kanina, yung sine pi over 2, di ba? Itong sine pi over 2 is equivalent sa 1. Okay, therefore, ito is equivalent lang sa 1 square. Or that is simply 1. So, ang sagot dito is 1. Okay? So, kung i-check natin sa calculator, sorry. Check natin yan sa calculator, that is, okay, pi over 2, okay, pi over 2 minus x, no? And then, tangent of x. Okay, then calc natin. So, pi over 2, di ba? Okay, lagay natin pi, okay, sorry. Shift pi over 2. So, 0 yan, automatic, or math error yan. Sorry, math error pala yan. And then, kasi pi over 2 exactly. Pero, kapag pi divide 2, tapos mag-add tayo ng 0.0001, we are approaching pi over 2 and not exactly pi over 2, you would get approximately equal to 1. So, 1 talaga yan. Sagot yan. Okay? So, I hope nakuha nyo, no? So, last problem for the day. Evaluate the limits of x squared times e raised to the power of negative x as x approaches to positive infinity. So, kung atin tong ilagay sa directly dito, no? So, we have here positive infinity square. So, this is the same thing as positive infinity. At saka yung 1 over e over raised to the power of negative x. So, diba, that is simply 1 over e raised to the power of x. Kung ang x is positive infinity, you have here 1 over positive infinity. Tama ba? And 1 over positive infinity is 0. So, you would have positive infinity, and 0. This is an indeterminate form. So kapag ganyan, so apply natin yung rule, no? So yung x squared, ilagay lang natin yan dito sa numerator. Then yung e raised to the power of negative x, ilagay na naman natin dito yan sa denominator. Pero ito, that is simply equal lang sa dito, no? So that is x squared over e positive na yan. Kasi nag-change tayo ng positioning. From numerator, ginawa nating denominator. Okay? Then from here, you apply the L'Hopital's rule. Okay. Then we have here, yung derivative ng, derivative ng x squared? That is
2x.
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 Derivative ng e raised to the power of x.
E raised to the power of
E
x
pa
pa rin.
rin, di ba? So for example, we have here 2 tas infinity. This is infinity pa rin, no? Then this one is infinity. So infinity, infinity, that is indeterminate form pa rin. So you reapply. Okay, you reapply. So mag-apply ka ulit ng L'Hopital's rule. Okay. So ano yung derivative ng 2x?
2.
Okay, to derivative ng e raised to the power of x.
Same pa
Same
rin.
pa rin, di ba? So if you will evaluate x approaches to infinity, so you would get here what? Infinity, and then 2 over infinity. Okay, if you will evaluate 2 divide infinity, you would get 0. Kasi for example, meron tayong 2. Kahapon ba, di ba, 1 man yun. So 2 pa rin. Sample 2. Then divide natin yan positive infinity. Like for example, 99999. So you would get what? Approximately equal to 0. So yung sagot dito is 0. Okay, kung try natin yan ilagay sa calculator. So we have here alpha x square, then alpha e raised to the power of negative x, no? Then calc natin as x approaches to positive infinity. So lagay tayo ng malaking number. So for example, 5 nines. Okay, you would get what? 0. Kuha ba? You would get 0. So yung sagot dito is actually 0.